Now, the very important concept here, the matrix representation of a graph. How we can define a graph into matrix form. This is a very important concept while we solve the practical problem based on graph. So there are two principal ways to represent a graph G with the matrix. First is incidence matrix relationship and दूसरा है adjacency matrix representation. So we have two types of representation. First है आपका incidence matrix representation and second is adjacency matrix representation. Okay, so first we discuss ki what is the incidence matrix representation. For we are defining for simple graph. Both first we define for simple graph. Okay, we also define for multi-graph. We also define for directed graph. So first we defining incidence matrix relationship representation and adjacent matrix representation for simple graph. That means undirected graph. If an undirected graph G equals to V comma E with no self loop consists of n vertices and m edges, then the incidence matrix is an n by m matrix defined by C equals to Cij and defined by. We define a matrix C equals to Cij. Cij is the element of matrix. Okay, so what will be element of matrix? C equals to, that means Cij equals to, it will be 1 or it will be 0. It will be either 1 or 0 if the vertex, when it will be 1, if the vertex Vi is okay incidence by Ei. That means if any edge is incidence on any vertex, then we put 1, otherwise it will be 0. If not incidence, we put 0 otherwise. This is a simple concept. If any edge is incidence on any vertex, then put 1, otherwise 0. In incidence matrix, the row represents the vertex and the column represents the edges. So while we define, so this will be n by matrix. So n denotes the number of vertex and m denotes the number of edges. The number of ones in an incidence matrix of the undirected graph is equal to the sum of the degree of all the vertices in a graph. This is the basic concept we will discuss after the example. Graph is given here and we have to find the incidence matrix of the given graph. So what will the incidence matrix? We discuss here. We consider an example. Okay, what is the example? We consider suppose this is V3, this is V1 and this is V2 and this is V4. The edges is, this is E1 and this is E2, this is E3, this is E4, this is E5. This is a graph. Okay, now we have to find the incidence matrix of this graph here. Okay, so how many vertex? First we define the vertex set. How many vertex here? V1, comma V2, comma V3, comma V4. And what is the edge set? E equals to how many edges? E1, comma E2, comma E3, comma E4, comma E5. Okay, so that means the order of the matrix will be 4 by 5 because there is a 4 vertex and 5 edges. So the order will be 4 by 5. Okay, so we define. So here what is your n? N equals to 4, number of vertices is m equals to 5. Now in incidence matrix, row represents vertices and column represents edges. So we define, now we define C equals to, column represents edges and this is V1, comma V2, V3 and V4. Row represents vertices. Okay. Now E1 is incidence on V1. Okay. E1 is incidence on V1, so we put this is the 1, and also incidence on V3. So E1 is not incidence on V2, so we put 0, is put 1, and E1 is not incidence on E4, so it will be 0. The column of the matrix is 1, 0, 1, 1. Similarly, E2 is incidence on V3 as well as on V2. Okay, so we take the E2. So E2 is incidence on V1. Not incidence is not on V1, so put 0. The incidence on V2 put 1. Incidence on V2 V3 1, and incidence on not incidence on V4, so put 0 here. Similarly for E3 is incidence on V2 as well as on V4, so 0, then 1, 0, 1, 0. Okay. Next, E4 is incidence on V1 as well as on V4. So for E1 is 1, otherwise 0, 0, and for V4 is 1. E5 is incidence on V3 as well as on V4, so we put 0, 0, 1, 1. Then order of the matrix is 4 by 5. This is the incidence matrix of a given graph. Okay. This is the E1, E2, E3, E4, and this is V1, V2, V3, V4. This is the matrix. This is the incidence matrix of given graph. Now some observation about incidence matrix, because this is also related to how we find the degree of each vertex and what is the relationship between them. The sum of each row is equal to the degree of the corresponding vertex. Sum of each row is equal to the degree of corresponding vertex. Suppose if you have to find the what is the degree of V1, so here the sum of row of these elements, that is 2, and here is degree of V1 is also 2. So sum of each row is equal to the degree of corresponding vertex. What is the degree of V3? Degree of V3 is here 3. Degree of V3 is 3. So here just we sum the elements of V3, row V3, we get 1 plus 1 plus 1 plus, this is 3. The first observation. Each column of incidence matrix has exactly ones, since every edge is incidence on exactly 2 vertices. देखिए, this E1 is incidence on 2 vertex, V1 and V2. So each column will have exactly 2 ones. Exactly once. देखिए, here is. Okay. If a row has all zeros, then the corresponding vertex is an isolated vertex. Okay. So in this graph there is no any isolated vertex. Okay. So all row having ones, at least once. So this is not a isolated vertex. For parallel edges, the corresponding columns are identical in incidence matrix. Suppose we take one example here. Suppose V1 and V3 is also having the parallel edges. Okay, means the 2 edges having the same initial vertex and terminal vertex, then the edges are known as the parallel edges. So we define here another edge E6, then it is E6. Okay, then E6 will be incidence on V2 and V3, V2 and V3, V2 and V3, so put 0. Okay, just to see, E2 and E6 are parallel edges, so their corresponding column will be identical. So they see C's and E2 and E6 columns are identical. Okay, so there are some observations for incidence matrix, and these observations are very helpful. Those students who are preparing for the IIT JEM, those who are preparing for the higher studies, this will be very helpful for the students.